So grade 11 STEM, since it's already 4:05, habol na lang po yung mga ibang classmates ninyo sa ating virtual meeting. So let us formally start. Good afternoon, grade 11 STEM. Let me introduce myself first. I am Ma'am Patricia Abigail Perez, your teaching intern for this afternoon. Before we formally start, let us feel the presence of our Almighty God through prayer. Kindly lead the prayer. Wants to lead the prayer? Anyone? Okay, copy. King Alexander. Yes, Leia Bea.
In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done, on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Good afternoon po.
Amen. Good afternoon once again, grade 11 STEM. For your attendance, please give me a few minutes to screenshot our for afternoon. We have two excuses, si Mark Gabriel Junio and Oshwin Bautista. Wala na po bang excuse for this afternoon? Since I think wala na kasi wala nang nagsasalta, so let's proceed to the virtual classrooms rules and regulations. First, if you want to recite or say something, just raise your virtual hands and wait for your name to be recognized. Second, always mute your microphones unless you are called to answer or share something. Third, participate actively, and last but not the least, respect your teachers and your classmates. Are the rules clear, class? Hello?
Yes, ma'am.
Okay, thank you. So before we proceed to our new lesson, okay, copy. Maria So before we proceed to our new lesson, can anyone from the class who wants to share his or her learnings about the previous lesson? Anyone? Kung wala, magtatawag ako. Let's have Sofia Joyce Catalon. Andito ba siya? Hello? Hello, wala yata kayo na tandaan nung previous lesson. How about Leia Bea? Can you please share your learnings about the previous lesson?
Hello po ma'am. I apologize po. I was not able to attend the last meeting because I was not well po that day. Thank you po.
Okay. How about Mary Francine?
Ma'am, so last discussion po we talked about the Bronsted acids and bases po, ma'am.
Okay, thank you. Meron pa ba? May habol pa ba? I think wala na, so let us proceed. So before we proceed to our main topic, let's have a short activity. So this activity, I will share some rules and I want you to guess the terms on the presented riddles on the screen. Is it clear? So since, okay, thank you. So first, I indicate the acidity or basicity of a solution. What am I? Please flash the hint. The hint is already presented on the screen. It is 2 words. Any guess? The first word is power. Blue. Yes, Casey Valdez.
Power of hydrogen po.
So please flash the correct answer. Yes, it is the power of hydrogen. Next. Number 2. I am the solution have pH is greater than 7 because H concentration is less than 1.0 times 10 raised to negative 7. What am I? Kindly flash the... Yes.
Alkaline solutions po ba?
Please. Yes, it is correct. Next. I may be classified as binary or ternary. What am I? It is easy. Okay, one word. Anyone? Yes, Shan. Shan, you are recognized.
Ma'am, hindi ko po sure pero acid po ba?
Kindly flash the... Yes, it is correct. It is acid. And last, I have an acidic hydrogen bonded. What am I? Okay, the hint is already present on the screen. Yes, Mary Francine.
Is it tertiary acids po ba?
Kindly flash now the correct answer. Yes, it's ternary acids. So these 4 terms presented on our activity, which is the power of hydrogen, alkaline acids, and ternary acids, these 4 terms are some of the terms that we will discuss in our topics for this afternoon. So we have 2 topics, the lesson with pH and lesson 7.3, strong acids and bases. Next. First, let us talk about measuring acidity with pH. In the first slide, in 1909, Danish chemist Søren Peter Lauritz Sorensen introduced the pH scale as a way of expressing the concentration of H or hydrogen in diluted solution. So, the picture presented on the screen is none other than the Danish chemist Søren Peter Lauritz Sorensen. The chemist famous in pH scale as a measure of acidity and alkalinity. Next. For the first bullet, pH stands for power of hydrogen that indicates the acidity and basicity of a solution. Maybe kung na-encounter nyo yung, excuse me, yung potential of hydrogen, it is the same with power of hydrogen. Maybe tatanungin nyo ako kung ano pinagkaiba ng power of hydrogen and potential hydrogen. Ang sagot dyan is, there are the same. Wala silang pagkakaiba. So here, the measures of how acidic or basic water is. The range is from 2 to 14. Take note of this class. The pH range is 0 to 14. With range 7 is being neutral. So kapag ang pH range ay 7, it is neutral. pH of less than 7 indicates acidity. On the other hand, when the pH is 7, it indicates basicity. The second bullet, the P in pH refers to the power of exponent of hydrogen concentration. So take note of this class. Next. In this slide, states that the pH of a solution of the reciprocal of the H molar concentration. So kung sinabi nating pH, it is mathematically defined as logarithm. Kaya kung mapapansin yung pH formula natin is meron siyang logarithm. Next, the equation presented on the screen is the equation on how we come up on the pH formula. So, first step, pH is equals to logarithm 1 all over H. Next, copy the logarithm. Reciprocal of 1 all over H positive to come up with H is positive raised to negative 1. And next, para mawala yung, mamaya ma'am, please pakibalik po. Next step, para maalis natin yung negative exponent, so we need to transfer the exponent negative 1 to the base to come up with negative logarithm H raised to positive. So, our formula for pH will be pH is equals to negative logarithm H positive. Is it clear, is it clear, class? Hello?
Yes po, ma'am.
Next. This slide states that at this point, take note that H also refers H3O or the hydronium. When we said H3O, it is hydronium, and that they have the same value. So later on, pag you encountered H3O on the pH formula, don't be confused on that because it is the same with the H positive because they have the same value. Next. Here, the equation that the screen shows that on how we come up with 3O or the hydronium. Simply, we will add H2O or water plus the hydrogen. So, the H2O, wait. Here we come up with H3O because in H hydrogens, that results to H3NO. The positive exponent of H or hydrogen will be transferred to hydrogen. Next. In this slide states that since a neutral solution has the concentration of 1.0 times 10 raised to negative 7, its pH can be calculated using the pH formula. So kapag neutral solution, it will be 1.0 times 10 raised to negative 7. Next. So here, the equation, the equation for this is on how we get the neutral solution or neutral range of the pH. So we use the pH formula. pH is equals to negative log H positive. Then copy the negative logarithm, then substitute the neutral solution, which is the 1.0 times 10 raised to negative 7 to come up with 7.00 range. As I said a while ago, when the range is of pH is 7, it is neutral. Next. Here on this slide says that acidic solution have pH less than 7 because or the concentration is always greater times 10 raised to negative 7 as implied by the negative logarithm. While for alkaline solution have pH is greater than 7 because each concentration is less than 1.0 times 10 raised to negative 7. For alkaline solution, it is more convenient to use the term POH, which is based on OH. So don't be confused with the acidic solution and the alkaline solution. When we said acidic solution, its pH is lesser than 7. And for alkaline solution, its pH has greater than 7. And for alkaline solution, we will use the term POH. Unlike in acidic solution, we use the term pH. Next. So here, the equation presented on the screen is what we call the POH solution. POH is equals to negative logarithm OH. Next. The relationship between pH and POH can be derived from the equilibrium expression of the autoionization of water. Next. So here, the solution presented on the screen shows about the relationship between pH and POH. So let us discuss this one. Kw is equals to H3O OH equals 1.0 raised to 14. When we said Kw, it is the pH POH. And don't be confused on 1.0 times 10 raised to negative 14 because it is given. Next, taking logarithm on both sides. So it becomes log Kw equals log H3O positive OH negative equals log 1.0 times 10 raised to negative 14. Then, on the next step, we will simplify log 1.0 times 10 raised to negative 14. So, copy the other side. Log H3O positive OH negative. Then let us simplify the log 1.0 times 10 raised to negative 14. So, as you can see, in 1.0 times 10 raised to negative 14, we have the exponent of negative 14, right? Tama ba? So, walang nag-response. Then, exponent negative 14 will be transferred on the base. So, we have negative 14 on the base. Then, the base 10 will be transferred at the bottom of the logarithm. So, kaya nagkaroon tayo ng 10 doon sa logarithm. Then, the 1.0 base will become its exponent. So we come up with negative 14 log 10 raised to negative. The next, here in next step, sign to come up with pH plus copy the log H3O positive plus log OH equals negative 14 kasi na-cancel out na yung ating logarithm. The logarithm cancel because for us to come up with the negative 14 on the other side. Next. On the next step, we will apply negative on both sides because I forgot to tell you a while ago that pH and POH is also defined as negative logarithm. For pH, it is defined as negative logarithm taken from H3O or hydronium, while the POH is defined as negative logarithm taken from OH. So we will apply negative for this step. So it will be negative log KW equal negative log H3O positive plus negative log OH negative equals negative of negative 14. Then next, now we will come up with the sum of pH plus POH. Then, instead of logarithm, we will put P beside on of the KW. So, we come up with PKW equals pH plus POH equals to 14. It becomes 14 because negative of negative is equals to positive. Then now it is the final formula for pH and POH relationship. And therefore, the sum of pH and POH for a solution will always equal to 14 because of H3O or the hydronium and OH is 1.0 times 10 raised to negative 14. So take note of this plus the sum. So take note the sum of pH and OH which is 14. Next. Please ano na yung sample problem. Na lahat. So now let's proceed to sample problem. But before, I want you to get your paper, pen, and calculator for you to follow me in solving the sample problem. I'll give you 1 minute to get all your things for the problem solving. Your timer starts now. So time's up. Time's up, class. Please raise your virtual hands if you already have your paper, pen, and your calculator. Please raise your virtual hands if you already have your paper, pen, and your calculator. Mukhang wala pa yatang nagre-raise hand. Meron na ba kayo? So, okay, I think meron na. So, the first problem, calculate the pH of solution with concentration of 0.010 moles of hydrochloric acid. HCl is hydrochloric acid. Number 2, what is the concentration of H in a solution with a pH of 4.73. And third problem, calculate the pH of A 0.00015 moles of NaOH or sodium hydroxide solution in a strong base and completely dissociates in water. Next. So let's solve this problem. I want you to follow me. Calculate the pH solution with concentration of 0.010 moles of hydrochloric acids. Here, since we are looking for the pH, we will going to use the pH formula. pH is equals to negative logarithm H or hydrogen. Next, substitute the concentration. Negative log 0.010, then input it in your calculator to come up with the answer. The final answer for pH is 2.00. Did you come up with the same answer, class? Kung nag-solve kayo? Hello? Yes, 2.00 din ba ang nakuha niyong sagot?
Yes, ma'am.
Thank you. How about the others? 2.00 din ba? Okay, I think same lang din ng nakuhang answer kasi it's because silence means yes. Next. Number 2, what is the concentration of H in a solution with a pH of 4.73? So here, since the required is the concentration and the pH is given, which is 4.73. So we will derive the pH formula. To derive the pH formula, the pH will be transferred on the side where the concentration came from, and the concentration will be transferred on the other side. And instead of logarithm, here we will use anti-log because the required is the concentration. Next. So our equation is H plus is equals to anti-log pH. Then substitute the value of pH. The value of pH 4.73 will become negative because, as you remember, I said a while ago, pH is defined as negative logarithm. So the value of pH will become negative. So to input the anti-log on the calculator, just press the shift, log, and the So have you watched the video presented on the screen? Hello? Have you watched the video on how to input anti-log on the calculator or scientific calculator? Yes or no? Hello? Wala, tulog na yata sila. So our final answer is 1.9 times 10 raised to negative 5 moles. On the video, the answer is 1.86. Kasi hindi pa siya na-round off, kaya 1.86. Kapag na-round off na siya, the final answer will be 1.9 times 10 raised to negative 5. Did you come up with the same answer? Hello, class. Grade 11. Am I audible po ba? Okay, I think nag-come up naman kayo sa um, next ay sa same answer. Next. For the third problem, calculate the pH of a 0.00015 moles of sodium hydroxide solution is a strong base and completely dissociates in water. Next. Note, for NaOH, OH is also 0.0015 moles because NaOH dissociates completely in water. Thus, the pH and pOH are calculated as, here's our solution. So we need to find our pOH. We will use the pOH formula for this. pOH is equals to negative logarithm, substitute the value of OH, which is 0.00015, then input it in your calculator to come up with 3.82 pOH. Did you come up with the same answer, class?
Yes, ma'am.
Okay, thank you. Next. So here, instead of using the pH formula, the negative logarithm H plus, because the hydronium is not given. So we will use the pH form. We will use to form the formula that we are going to use in finding the pH is the pKW minus the pOH. The pKW, or the sum of pH plus pOH, is equals to 14.00. As if, kung naalala niyo yung pinag-usapan natin kanina na sum of pH and pOH is 14. So, yun ang gagamitin natin dito. So, now let's compute the pH. pH is equals to 14.00 minus 3.82 to come up with 10.18. Did you come up the same answer? Hello? 10.18 din ba ang nakuha niyong sagot? So, I think it's yes. And para mas malinaw tayo, dito sa pagkuha ng pH dito is, ang formula is pKW minus the pOH. Gagamitin nyo itong formula na to kung if the hydronium or H is not given on the problem. Next. So let's proceed to problem solving. I want you to answer these two problems, and I will give you 5 minutes to answer these problems. Timer starts now. 2 minutes. One minute. Five, four, three, two, one. Time's up, class. Let's now solve the two problems. For number 1, who wants to share his or her answer? Anyone? Yes, Casey Valdez.
Sa number 1 po, yung nakuha ko pong sagot is 2.6989 or pag na-round off po, magiging 2.7.
How about the others? Meron pa ba mag-share? I think wala na. So let's check the answer of Casey Valdez. So for number 1, since we are looking for pH, so we will use the pH formula, the negative log H. Then next, substitute the value of the concentration, which is 0.002.0, then input it in your calculator to come up with the answer. So the final answer is 2.70. So correct. How about the others? 2.0 din ba ang nakuha ninyong final answer? Yes or no? Did you come up with the same answer, class, sa iba?
Yes, ma'am.
Okay, thank you. Next, for number 2. Who wants to share his or her answers? Did you come answers for number 2? Oh, it is already presented on the screen. So here, since we are looking for the concentration, so we will use the formula for concentration. So H plus is equals to anti-log, then substitute the value of pH, the 2.34 negative. It will be negative because the pH is defined as negative logarithm. Then input it in your calculator to come up with 4.5 times 10 raised to negative 0.3 moles. So did you come up with the same answer, class? Yes or no? So I think it's yes. Next. So we are done with the measuring as acidity with pH. Now let us proceed to strong acids and bases. Next. Strong acids and bases. On the first bullet, strong acids and bases ionize almost completely, while weak acid and bases do so partially. So strong acids and bases ionize almost completely because their conjugate bases are weaker bases than the water, while the weak acids and bases only partially because it contains only a small proportion of hydroxide ion and concerned basic radical and a large proportion of the undissociate molecule of the base. Is it clear, class? I think it's yes. So here are some examples of strong acids. First is the hydrochloric acid or HCl. It is used in the production of batteries and fireworks. So yung mga batteries natin and mga fireworks para makapag-produce ng mga ganyang products is we need hydrochloric acid for that. Next example is hydrobromic acid or HBr. It is used to as a source of bromine in industrial system. And last example is the hydroiodic acid or HI. HI is used for disinfectants. And examples for strong bases are the sodium hydroxide or NaOH. It is used to make a variety of everyday products like papers, soap, and detergent. So, yung mga papel natin ngayon na ginagamit at yung mga sabon na ginagamit natin sa katawan is kinakailangan ng sodium hydroxide para makapag-produce ng ganyang product. And another, potassium hydroxide or the KOH. It is used in making paints. For the second bullet, this follows that the ionization constant of strong acids and bases are relatively larger than those of weak acids and bases. So the ionization constant of strong acids and bases is larger because the ionization constant increases as the strength of the acid increase. And take note also that the stronger acid, the weaker its conjugate base. The stronger base, the weaker its conjugate acid. Take note of this, class. Uulitin ko. The stronger the acid, the weaker its conjugate base. And the stronger base, the weaker its conjugate acid. Did you understand, class? Nakuha ba? Hello? I think it is yes, kasi walang nag-response. Next. So let us proceed with the classifications of acids. First, it's the binary acid. When we said binary acids, it is composed of only two elements bonded, like the examples presented on the screen, the hydroiodic acid or the HI, and hydrochloric acid or HCl. Their strength depends on the bonding energy between the hydrogen atom and the halide. Next. And for acid strength, the HF, HCl, HBr, and HI are examples of binary acids. HF is hydrofluoric acid, HCl is hydrochloric acid, and HBr is hydrobromic acid, and HI is hydroiodic acid. Dito, naka-arrange na sila from weak acid to strongest acid. Here, the hydrofluoric acid is considered the weakest because of the hydrosonium ion attached to the fluoride ion. It isn't free to function as an acid, thus limiting the strength of HF in water. The hydroiodic acid is the strongest because it is made by the hydrogen iodized in water and completely loses its ion in a solution. So take note of this, class. In this example, the hydroiodic acid is the strongest and the weakest is the hydrofluoric acid. Next. So we are done with the binary acids. Now let's proceed to the ternary acid. When you said ternary acids, it is composed of three different elements. Unlike in binary acids, we only have two elements bonded. The ternary acid are also referred to as oxoacids or oxyacids. Ternary acid is also referred as oxyacids or oxoacids because it is the acid containing oxygen. It is a compound containing hydrogen, oxygen, as well as at least just one element with at least one hydrogen atom bound to oxygen and capable of dissociating to create the acids H, cation, and anion. So is it clear, class? Yes or no? Diyan pa ba kayo? Grade 11 STEM? Ay, mukhang wala na yata. So, proceed. On the second bullet, ternary acids may be further classified as monoprotic, diprotic, or polyprotic depending on the number of protons an acid molecule can donate. So, when we said monoprotic, it donates only one proton, while the diprotic yields 2 hydrogen ions per molecule. And the polyprotic, this acid can lose several protons per molecule. So the keyword for monoprotic is only one proton donates. Like it only donates one proton or hydrogen atom. And for diprotic, it is yields with 2 hydrogen ions per molecule. And for polyprotic, these acids can lose several protons per molecule. So next. So let us proceed to the relative strength of the ternary acids. First, the oxidation state of central ions. So here, oxyacids with the same central atom, the one whose central atom has a higher oxidation state is stronger. So here, the atom has higher oxidation, it is the stronger. So malalaman natin kung mas maraming oxidation sa isang atom kung depende dun sa number ng oxygen na presented dun sa isang atom. Example of this is the sulfuric acid and sulfurous acid. Sulfuric acid is the strongest because it has the higher oxidation, and the sulfurous acid is the weaker. So the oxygen presented in sulfuric acid is 4, while the sulfurous acid is 3. So sulfuric acid is the strongest. Next example is for HClO, HClO3, HClO2, and HClO. So parehas lang dun sa previous example na ang strongest dito is the perchloric acid because of the atom has 4 oxygens presented, and the hypochlorous acid is the weakest. So next. Excuse me. Excuse me. Next, the electronegativity of the central atom. Here, the oxyacids with different central atoms but similar oxidation states that the one with the more electronegative central atom is stronger. Consider the different acid with chlorine, bromine, and iodine as their central atom. So here, we can identify the electronegativity by looking on the periodic table. The electronegativity will increase if you move from left to right across a period and decreases as you move down a group. Here, on the example, the HClO4 is the strongest and the HIO or the periodic acid is the weakest. Ibibigay ko na yung electronegativity nitong tatlong examples para hindi na kayo ma-confuse. The electronegativity for HClO4 is 3.0, and For HBRO is 2.8 and for periodic acid it is 2.5. So ang pinakamataas ng electronegativity is the HClO for have 3.0. So it is the strongest. Next. Okay lang bang mag-extend tayo, class? Hello? Okay lang bang mag-extend tayo ng kahit saglit lang? Hello? Okay. Next, the electronegativity of an atom attached to the central atom. Here, oxyacid with the same central atom and oxidation states the electronegativity of an atom attached to the central atom affects the strength of the acid. So, example of this is the HSO3F, H2SO4, and H2S2O3. Here, the fluorosulfic acid or the HSO3F is the strongest because it has the most electronegative atom which is the fluorine. So it is the trivia for all. Fluorine has the most electronegative atom with the total of 3.98. And the thiosulfic acid, which is the H2S2O3, is the weakest because it contains the least negative atom sulfur attached to the central sulfur atom. So kung makikita nyo yung figure ng H2S2O3 sa picture, yung isang sulfur is naka-attach dun sa central atom, which is the sulfur. Kaya ito yung ating weakest. While as compared to H2SO4, since isa lang yung sulfur, kaya mas weaker pa rin yung H2S2O3. Next. Next. Servines. So let's proceed to pH of the strong acids and bases. For the first bullet, a strong acid completely dissociates in water, producing hydronium ion and the conjugate base of the acid. This is the reason they are also described as strong electrolytes. When we said electrolytes, it is the medium containing ions that is electrically conducting through the ions but not conducting electrons. On the second bullet, the concentrations of the hydronium ion and the conjugate base are both equal to the initial concentration of the acid. So strong acids like HCl have Ka values in the vicinity of infinity. This implies that the dissociation of HCl is virtually completed and the equilibrium lies completely to the right, and therefore the concentration of the hydronium ion and the conjugate base are both equal to the initial concentration of the acid. Next. So okay lang ba sa inyo na mag-extend tayo kahit saglitan lang? Grade 11 STEM? Hello? Okay lang ba? So, continue. For the hypothetical strong acid HA or hanium, the dissociation is represented as HA plus HO2 and its product is H3O plus A. So we come up with H3O plus A because in H2O plus in HA and H2O we have 3 hydrogens, right? And 1 oxygen. The hydrogen in hanium will be transferred on the H2O to come up with H3O positive, and the A in the HA will be separated. So next. And this slide states that common strong acids includes HCl, HClO4, HNO3, and H2SO4. So these are the common strong acids, although for H2SO4 only the dissociation gets completed. So yung tatlong strong acids dito, which is the HCl, HClO4, and HNO3, dissociates almost completed, but H2SO4, the dissociation of this gets completed because it is very strong acids compared to the three. So next. So here, let us answer the problem. A 0.010 moles of hydrochloric acid solution means that there are 0.010 moles of H3O ions and 0.010 moles of chlorine ions in the solution. The pH of the solution can then be calculated directly from the given concentration of the acid. So here, we will use the pH formula. Servines. pH formula is equals to log H3O positive. Then, next, substitute HCl to the H3O positive because according to the problem, 0.010 moles of H3O ions and are only the same. Next, then substitute the value of the HCl, which is 0.010, then input it in your calculator to come up with the final answer. And the final answer for this is 2.00. Next. Bilisan na natin dahil time na. The same principle applies to strong acids, strong bases of alkali metal hydroxide such as NaOH and KOH. A 0.010 moles of NaOH or sodium hydroxide solution will produce 0.010 moles of sodium and 0.010 moles of OH ions. The pOH is calculated directly from the concentration of the base. The pH is derived from subtracting the pOH from the 14 pKw. So here, we are talking about the base, so we will find the pOH first before the pH. So next. So we will use the pOH formula. Negative log OH, then substitute the OH, the value of OH, which is 0.010, then input it in your calculator to come up with 2.00 pOH. Next, for the pH, since we are talking all about the bases, so instead of the pH formula negative logarithm H3O formula, we will use the formula for pH is equals to pKw minus the pOH. So the answer for this is 12.00. So on the first problem, we are talking with the acid, so we don't need to find the pOH for that problem. Here we are talking with the bases, so we need to find the pOH first before the pH. And the formula that we are going to use to find pH is pKw minus pOH instead of pH is equals to negative logarithm H3O positive. Next. So let's proceed to sample problem. Calculate the pH of the following acids or base. Number 1, 0.0010 moles of hydrochloric acids, and number 2, 0.015 moles of sodium hydroxide. So let's answer this. For number 1, we will use the pH formula for this. Sir, pakiano na. pH is equals to negative logarithm H3O positive. Then next, substitute the HCl from HCl to H3O positive. So it will be negative logarithm HCl. Then next, substitute the moles of HCl. So negative log 0.0010 to come up with final answer, the 3.00. So did you come up with the same answer, class? 3.00? Hello? I think it is yes. Next, for number 2. So here, since NaOH is a base, so we need to find the POH first before the pH. So we will use the pH formula, POH rather. POH is equals to negative logarithm OH. Then substitute the NaOH to OH. So it will become negative logarithm NaOH. Then substitute the value of NaOH or concentration. Negative log 0.015. Then input it in your calculator. Negative logarithm 0.015 to come up with the final answer, 1.82 POH. Next. Servings. Next. Servings. Ay, ulit. So here's for number 2, solving for pH. For here, we need the presence of the sum of the pH plus POH which is the 14.00. So as instead of pH is equals to negative logarithm H3O will be used as formula, but since the H3O is not given and we are talking with the base, so the formula for pH will be pKW or 14 minus the POH. So let us substitute it. pKW is equals to 14 minus the POH of the sodium hydroxide, which is the 1.82. Then input it in your calculator to come up with the final answer, the 12.18 pH for the sodium hydroxide. So reminder lang, when it comes to pH of strong acids and bases, kapag bases ang pinag-uusapan, we need to find its POH first. Then, after we solve for its POH, now we can proceed to pH solving by subtracting 14.00 and its POH. And for acids, we don't need to find its POH because its pH can be calculated directly from the given concentration. So is it clear, class? Yes or no? Am I audible po ba? Okay, I think it is clear. So for your evaluation, so sir, please kindly take a screenshot of this for your evaluation. That will serve as your assignment, and the deadline of submission will be next week, Tuesday, until 12 noon. So every 5 minutes late submission will correspond to 1 point deduction. So have a screenshot of this. Take a screenshot rather. And I will be sending you the link. Yes, Stephanie Joyce de la Cruz.
Ma'am, sabi po ng advisor po namin, bawal daw po magbigay ng assignment during Friday po.
Okay, so kailan ang asynchronous nyo, time ninyo?
Monday po ata, ma'am. Ay, Tuesday po pala, Tuesday.
Okay, so this evaluation will be conducted na lang during your asynchronous time. Okay ba yon? During asynchronous time nyo na lang? Every Tuesday? Hello?
Yes po, ma'am.
So I'll be sending you the link kung saan nyo i-submit. So for a while. So for a while, nagkakaroon ng problema sa sending ng link. Yes, Stephanie Joyce de la Cruz.
Ma'am, exam week po pala next week.
Okay, so since exam week nyo pala, siguro I will not give this evaluation na lang para magkaroon kayo ng enough time for your preparation for your exam week. Okay ba? Hindi ko na ibibigay ito as evaluation para mas magkaroon kayo ng mas mabang time for preparation para sa inyong exam. Okay ba? Okay, so again, yung ipapa-evaluation ko is hindi ko na siya ibibigay as your evaluation, and para magkaroon kayo ng enough time para sa inyong preparation for your exam week. So God bless all of you po sa inyong exam week. So that's all for my discussion for this afternoon. I hope you learn a lot on our topic on this afternoon. So before we leave, may I request everyone to please turn on their cameras for our photo opportunity. Hello. May I request everyone to open their cameras. Wala pang nag-open ng cam. Oh, si Robin nag-open cam na. Si Robin lang ba? How about the others? O si Teofilo? Sila lang ba? Wala na po bang hahabol? So 5 seconds. 1, 2, 3, 4, and 5. So at the count of 3, wear your best smile. 1, 2, 3. Another one. 1, 2, 3. So that's all for today. You may now leave the virtual meeting. Class dismissed. Thank you, Grade 11 STEM.
Bye, ma'am. Thank you po.
Bye. Thank you.